Good afternoon, everybody. Welcome to Tibbetts Physics. What is crappening? I think I've aged about 10 years since I last saw you. Anyways, today we're going to look at conservation of momentum. And in order to do this, we're going to set up LOL diagrams. And that's going to help us organize our information. So let's read the problem first. A 500 kilogram shark moving at 4 meters per second to the right swallows a 1 kilogram fish moving to the left at a velocity of 100 meters per second. What is the velocity of the shark after it eats the fish? So we're going to make an LOL diagram. The first L is for the momentum before, and the second L is for the momentum after. So let's look at each thing. Shark moving at 4 meters per second to the right. Well, the shark is moving, so it has momentum. So we're going to make a little bar for it and say M1V1. A 1 kilogram fish is moving to the left. It has momentum. So we'll call that M2V2. And then, in this case, the shark eats the fish, so they combine their masses. So afterwards, we have M1 plus M2 times their combined velocities. So from here, we're going to write our formula. Conservation momentum says everything before is equal to everything after. And that's the sum of the momentum before and the sum of the momentum after. So the shark has momentum. So we've got M1, V1, V4 for the shark, and the fish has momentum, so plus M2, V2, V4 for the fish, and that equals the combination of their momentums, the combination of their masses. So we have M1 plus M2 times the velocity after. The reason they're combined, the masses, is because the shark eats the fish, so the masses of the system is combined. So we're solving for the velocity after the combined shark and fish. To do that, all I have to do is divide by M1 plus M2. So V after is equal to M1 V1 before plus M2 V2 before over M1 plus M2. And let's just plug and chug. V after is equal to 500 kilograms times, 4 meters per second, plus the momentum of the fish before. The fish is 1 kilogram times 100 meters per second, all over the mass of the shark plus the fish. So 500 kilograms plus 1 kilogram. You plug it in our calculator and we get the velocity after the combined fish and shark is 3.8 meters per second. Alright, now we're going to look at still a conservation momentum problem, but a different scenario. This time let's draw our picture first, and we'll label things as we read it. So we have before and after. Alright, so before, a 50 kilogram person running 15 meters per second to the right. He's moving, he has mass, he has momentum. M1, V1. Runs into a 100 kilogram stationary person. Stationary means no momentum. Alright, after, the 50 kilogram person bounces backwards. So he has momentum, but now he's moving backwards. And the 100 kilogram person moves forwards at 8 meters per second. So now that person has momentum. M2, V2. And we know from before, the momentum before, the total momentum before is equal to the total momentum after. So from our LOL diagram, we can make our formula, knowing P before equals P after. So let's look at before. We have M1, V1, before. the 100 kilogram person doesn't have momentum. So let's go to after, M1V1 after, plus M2V2 after. And we're trying to solve for V1 after. So let's subtract M2V2 and divide by M1. That leaves us with M1V1 before minus M2V2 after all over M1. Plug and chug. Let's see here. 50 kilograms times 15 meters per second minus 100 kilograms times 8 meters per second all over 50 kilograms gives us a velocity, I should have equals V1 after, and we get V1 after is equal to negative 5.6 meters per second. And it should make sense that it's negative 5.6, since from our drawing and our information, the person bounces backwards. And 1v1. That's it for now. Next time we'll look at 2D problems of conservation of momentum. Have a great night.